everybody, welcome to Fiveable Spring Cram Session for AP Statistics. I am beyond excited about getting this spring cram session going. It is going to be a fantastic cram session. I just am thrilled. Fiveable has tons of great resources. I'm super excited to partner with them over the next 2 months and be a part of what they're doing as a great preparation for you guys for the AP Statistics exam coming up on, I believe, May 17th. So we are going to go started. I see some people in the chat already. Definitely take advantage of that. One thing I do want to make sure you are aware of is we have an awesome TA, which I already see him in the chat as well, Sander, who is going to be kind of moderating the chat during streams and is also super active on the Discord channel. I'm kind of new to Discord, so I'm kind of figuring that out as we go. But we are going to be using that to kind of communicate. After the stream, you can hop over there and ask questions, make comments, and connect with me and Sander on any personal questions that you had about the stream and that sort of thing, okay? So the way this is sort of going to work, you kind of see my screen layout, left, and also in the top right, you can see, I probably pointed the wrong direction, there we go. Over here in the top right, I'm a huge hockey fan, so I'll probably incorporate some hockey questions throughout our streams this time. Hockey and Takis. I always come up with a Takis question, so be on the lookout for a question about Takis. It's my favorite snack food. So anyways, you can see the Fiveable social channels over here up above as well. Over here to your left, I have put a QR code. I hope that works. I'm a little bit unsure if the QR codes are going to take you to the website I want you to. I couldn't get it to scan on my computer, but I'm looking at a small screen. And we can also post those links in the chat when we're finished as well, or in the Discord channel. And then we're also going to do a data collection activity. That's what the Staplet QR code is for over there in the bottom left corner. So anyways, let's go ahead and get started. Today we are going to be looking at Unit 1, which is exploring one variable data. So throughout the course of AP Statistics, you look at one variable data and you look at bivariate data or two variable data. And then once you get to inference, you also kind of do the same thing. Like you look at an inference question, a confidence interval, or a hypothesis test for one variable, and then you also go for a two variable test. Okay. All right. So just a heads up, this stream is being recorded and it might appear on our website, YouTube, other public channels. If you ask a question, your name over there in the chat might also pop up. So just kind of, most of y'all have names that are not specific, which is probably best in the chat. So that is totally a great option for you guys. Again, our social media channels, Twitter, Instagram, YouTube, tons of great resources on there. Also, Fiveable.me. I know y'all found that because you signed up for the cram sessions. Tons of great study guides that myself and other great statistics teachers have written. Also, check out the other subjects, okay? I know I had students last year that joined me on the stats streams towards the end of the year, but also jumped over to other subjects and said that that was the reason why they passed the AP exam. So that was what I wanted to hear being a part of Fiveable, is that those cram sessions is what they believe took them over the edge and got them a passing score. So check those out for sure. Man, these captions are great. Five of Oil. Maybe we should buy up that domain name and have people directed to Fiveable from fiveofoil.com. Anyways. So some upcoming streams. Next Saturday at almost the same time, same place, we will be going over Unit 2, which of course is two variable data. And then later that week, we will be looking at the collecting data. That is the experimental design unit. A lot of people hate that unit. A lot of people love that unit. But it is definitely going to be on the exam. So make sure that you join us for those two. And go ahead and circle on your calendar. The big day, the grand finale, as we say, is the Cram finale. It is on Sunday, May 16th at 1 p.m. Eastern Time. If you're on Central Time like me, that is at noon. And we are going to hit it hard and heavy. We're kind of, and you'll see at the end of this stream, the way that I'm kind of preparing for the Cram finale is at the end of every stream, looking at what is the key parts of the unit we're covering on that day. And then we're going to kind of bring all that together on that Cram finale. So that is going to be huge. I think it will give you a lot of confidence going into the exam, which you guys should be confident. You're showing up on a Saturday morning to study for an exam that's not for another 2 months. Like, you guys have got it, okay? Like, you are in the right place. You are doing the right thing. So you can be confident in yourself and going into that exam, okay? I know AP season is super stressful for you as it is for me, but you guys have got it. You are in the right place, the right time, okay? So in this stream, the main things we're going to cover are just a brief introduction to statistics, what exactly that is, and what our goal is in this class as we work through the end of the year. Different types of statistics, representations of categorical data, representations of quantitative data. That kind of gives you an answer to that that second topic. And then the really big thing that's important that Sander and I both agreed was the big theme for this chapter that you have to know is describing and comparing distributions. Okay, you will see that on the AP exam. So we will definitely take some time doing that today. So what is statistics? You guys go in the chat and just throw out what you think is statistics. Hopefully I didn't give it away. Got a little bit happy with my clicks there. So I want to see in the chat, what do you guys think statistics is? How would you define it? Analyzing data. Oh, I like analyzing patterns based on variation. That's really good. The study and understanding of chance processes. Measuring and taking samples of probability and data. Surveys, that's definitely a huge part of it. Jay, I love this. Using numbers and data to generalize phenomena. That's really good. So what I was going to ask in regards to... let's see, one of them had a word in there that was important. Aiden, measuring and taking samples of probability and data. So what I was going to ask is, what do we want to normally do with those samples? And Jay and Presh have kind of already answered that. We want to use that sample to form a generalization for the big picture, which is our population, okay? So we want to take our small picture, which is our sample, and we want to make a broad generalization to our population, which in the math world sometimes can be difficult because our generalizations that we make might not be right, okay? There is plenty of examples of statistical analysis that is made about a sample that proves to be incorrect about the population. Even though our statistics were fine and everything, but is that random chance probability, that chance process that something weird could happen, okay? So the definition that I came up with is collecting and analyzing data from samples to make predictions about a larger population in regards to, and I kind of narrowed it down here, to a true mean, which is like an average, or a true proportion of different variables. Okay, so if we're looking at a proportion or a percentage, then we can take a sample. If we're looking for information about the means or an average of something, we can also do the same thing. So here is an interesting graph that I pulled out of a book written by Tyler Vigan, which is Spurious Correlations. As I was preparing these slides, I came across this, and I couldn't wait till Unit 2. So this is looking at the number of injuries related to falling televisions every year, and the number of undergraduates in, I think, four-year universities. And we can see that in this crazy situation, those two things are correlated to a perfection. Clearly, those two things are not related, and that was the whole purpose of this book, is different values of statistics that are related that have nothing to do with each other. It was totally due to a random chance process. And this was one that I pulled out that was really funny. It was $2 on Amazon's Kindle store, and it's entertaining to flip through and read. One of them is the divorce rate in Maine versus the margarine consumption in Maine. So it was like the more margarine you consume as a household, the more likely divorce is to occur. Totally bizarre. One of my students brought that to my attention, and I kind of dug some more and found other funny correlations. So again, sometimes statistics is not always correct. Exactly, Owen. Correlation does not imply causation. Those two things are correlated randomly, oddly enough, however, clearly not causing each other. Okay, so it was a nice little funny example there as we're doing that. So types of variables, and I sort of gave it away to you a little bit in the little intro. What are the two types of variables that we typically look at in statistics? I'll give you all a second to pop those in the chat as well. Okay, I'm seeing some. There we go. Okay, so we could have one variable and two variable. That is true. And then we also have quantitative and qualitative. Qualitative is not the word that AP Statistics uses, strangely enough, but it is correct. And then categorical and quantitative are the two types of variables that we need. And I think it's really important in the very, very beginning to look at a set of data and determine which category, well, I won't say which category, which type of variable that falls into. Is it a categorical variable where someone falls into a category, or is it a quantitative variable? Once you do that, if you do it from the beginning, then that gives you the opportunity when you get to inference later in the year. It makes part of that process a whole lot easier, which we'll get to in just a few weeks. So yes, we have categorical and we have quantitative. And I see people also putting in the chat things like discrete and continuous. That is also true. We do have continuous data, things that fall like on a normal curve, and then we have discrete data where you fall into a bin. So that's almost kind of like categorical and quantitative. But there are some quantitative variables that also are discrete. Shoe size, for instance, like you couldn't get a shoe size of 12 and 7/8 unless you have some custom made shoes for some strange reason. But that is a quantitative. You could take the average shoe size. So categorical data is a type of variable in which each individual falls into a category or a set rather than being assigned a particular number. For example, if we were looking to poll everyone's favorite color, this would be categorical data. I couldn't take the average favorite color. Okay, that's just not a thing. Okay, so you like red, you like blue, you like green. Maybe you're more exotic and you like something like coral. Okay, but either way, you fall into a color category. I can't say the average is red and a half. Okay, that doesn't make sense. And then quantitative data is a type of variable in which an individual is assigned a quantity or a number. I always like to say, is this data averageable? Can I take the average of everybody's number? And if so, then it is quantitative. For instance, if we were to gather everyone's height in inches, this would be a quantitative variable because it's totally plausible to take the average height of everyone. That totally makes sense. Okay. This distinction, again, this is what I was talking about. It's important in the very beginning to bring up this idea because it's going to ultimately decide what type of inference procedure you do, what type of graph might be appropriate to represent your data. So another way of thinking about it is proportions, which is categorical data. If you're already in inference in your normal class, you would have, like a one prop z-test or a one prop z-interval. Okay, it's proportions because it's categorical. Means also would be quantitative. So if you're doing like a t-test or a t-interval. Okay, I see some good questions in the chat. So if you turn colors into numbers, then would it be quantitative? I don't really think so because I don't think it would make sense if I said the average favorite color was 2.5, which would be somewhere between red and yellow. That doesn't really tell you much. I guess technically, mathematically, you could do that, but I don't think that would really do much for the it wouldn't really do much for the statistical analysis. It would be much better to do a pie chart or a frequency chart and that sort of thing. And then, you couldn't really take the average, that sort of thing. A box plot wouldn't make sense because that difference between like a red and a yellow, there's my southern accent, I just said yeller. Between a red and yellow, it's not like a gradual change from red to yellow. It's more, and Sander pretty much summed that up. The numbers don't mean anything with zip code. So 35034 and 35035, like they might be close to each other, but there's no transition between the two, if that makes sense. Just like red being 2 and yeller being 3, I'm just going to go with it. That you have that, there's no gradual change. It's not a gradient change from red to yellow. It just is. Those are good questions. Those are really good questions. That almost makes you think you could turn anything into quantitative, and not quite. I think the good question to ask yourself is, does it make sense to average the data there? So let's go through some examples here, and we're going to open up the poll to see whether the following measurements are categorical or quantitative. So the first one is age in years. So categorical or quantitative? Starting to get some results here. And it looks like we are all in agreement at quantitative. We got a few people maybe saying categorical. All right, let's see what we got. So our results, mostly quantitative. A few people said categorical. And I can sort of see that where you could say you're either 2 or 3, you fall into a bin of 2 and 3. But again, I think the question comes down to, is it averageable? Can I average the age of someone and say the average age is 27.5? And that totally makes sense. You can have an average age that is between 2 years. That amount of being between 27 and 28 years actually has some meaning to it. So I think that it's totally plausible there to, okay? So I think that's a totally plausible. All right, I got to retype that, so I'm going to abbreviate, speed things up here. So the next one, all right. Month of your birthday. Okay. So categorical or quantitative? What do you guys think on this one? Cat or quan? All right, a few more seconds on this. All right, looks like everybody is on the same page here. And this was great because this one is a little bit tricky. 100% said categorical. I would 100% agree. Because when you're talking about the month of someone's birthday, it's tempting to say, well, I was born in May, so I could say it's 5. However, that 5 again is just a number assigned to a category. That number means nothing if you're looking at maybe the Chinese New Year, which they start their new year in February. So I'm not sure how they number their months if they follow the same calendar we do, but the first month of their year might appear a little bit different. Okay, so that number really is only assigned to the month in the order that we do them. That could be different in other cultures. So it does not necessarily, number really doesn't mean anything, kind of like the last example we had. Okay, so right or left-handed? Okay. I am going even shorter this time on the poll. Create, show, hide, open poll. There we go. So, man, these polls keep changing locations on me. C or Q? There we go. All right, getting a lot of votes here for categorical, which is definitely correct. We're not going to hang out there anymore. That one's a little bit more easier. So definitely, you're right or left-handed. Now, you could be ambidextrous and be able to write with both hands, and I'm super jealous of you if that's the case. I've tried to play drums before, and if you play drums, I don't know if anybody does that. You have to be able to use your right and left hand and your right and left foot. Not me. Okay, I can play guitar, so I can separate my right and my left hand a little bit, but you add feet in there, not for me at all. So if you play drums, I totally am jealous of that. Well, last one, and then we'll move on. So favorite sport? Categorical, quantitative. All right, again, categorical appears to be the favorite, and I would agree. Categorical is definitely the choice here, okay? Y'all know my favorite sport, hockey. I've already told you that, which is very odd. I'm from Alabama. Not very many people are hockey fans in Alabama, so I get a lot of strange looks. It's all football. But it is what it is. So anyway, so yeah, that is really important, guys, because when you're doing that, when you get into later things in the year, it's important to be able to determine, is it quantitative or categorical? Am I going to proceed with means or proportions with the way that I do my Z-test or T-test? Okay. So then the other one is taco or burrito. I really just wanted to use the emojis there. That is also categorical. So if we're looking at categorical data, we have different ways in which that can be represented. We could have a bar chart. That's a common way of doing it. We could have something like a frequency table. How many people said taco? How many people said burrito? How many people said Mexican pizza? May you rest in peace. You may have, another way you could represent that is a two-way table, which is when you have a two-variable data. So we're not going to spend much time on that today, or even next week, really, because that shows up a lot in the probability chapter, Unit 4. So that'll be in a few weeks. Also, you have a Mosaic plot, which is something they added into the AP curriculum last year. It didn't show up on the exam, at least none of the options that I saw, since everyone had different exams. But I would expect it to show up this year, being that it is a full exam. So here is an example of a bar chart. Okay, so you can see that everyone falls into a category. Every video game sale. You either are action, adventure, fighting, miscellaneous, platform, puzzle, racing, role-playing, shooter, simulation, sports, and strategy. So lots of Call of Duty games sold, lots of Assassin's Creed maybe, action, and I would say that's almost role-playing maybe. I'm not much of a gamer, but just using the ones I know that are popular. I'm surprised sports is not higher, but either way, you can see this as categorical data because you are falling into a certain category. You can't be both. You can't be between two categories other than action adventure, I guess. And then a mosaic plot. You might not have seen one of these, so I wanted to definitely show you that. So it gives you the counts of the amount of people who own. So you can see the general percentage of SUV, sedan, sports, and truck and wagon across everybody, and then you can see it based off of countries as well. So 25 people in Asia owned an SUV, 10 people in Europe owned an SUV, and 25 in the US owned an SUV. Okay, 90 in the US owned sedan, 78 owned a sedan in Europe, 94 in Asia owned a sedan. So you can see most people over the course of the whole world own sedan, and then you can also see by country how that is. So in the US, the percentage of people who owned a SUV is significantly higher than Europe, whereas a station wagon or a sports car is much higher in Europe. So you can see it's basically a two-way table graphically, but you kind of read it the same way, especially if it gives you the counts. If it doesn't give you the counts, you're looking at how much area it's going to take up. Okay. So those are two ways that you could represent a categorical data there. Yes, mosaic plots could very well be on the test. They added that into the course exam description before last year's administration, but being that last year was so crazy, it didn't show up. I would expect to see a multiple choice question on that. They felt it was important enough to add to the CED. I'm assuming with a full test, you would see a question on that. I would treat it almost the same way as a two-way table, which we'll go to in Unit 4. So we'll go more in depth on that. So then you have quantitative data, okay? And we're going to look at these mostly today because this shows up more often in the Unit 1 type questions you would see on the exam. So you could have a box plot. We'll definitely look at one of those. You could have a density curve, which is like a normal curve. You could see a dot plot, which is just a general representation of all the data points. You could see a histogram, which I see some of you discussing that in the chat over there. You could see a stem and leaf plot. If you have to create one of those, make sure you include the key. That will bump you from a 4 to a 3 on a free response question, just for not putting the 2 line 4 equals 24. Okay. One of those random little things I wanted to mention in case that does show up on a free response. So here's an example of a box plot. This is actually a side-by-side box plot. So the values on, so you're looking at male and female age for Oscar-winning actors. So you have the minimum female. Here you have Q1 female, the median, the Q3, and then this is the highest data point that's not an outlier, and we will discuss outliers in just a second. And then you have 3 outliers. And then you have the same thing for male. So you can see that like the males are typically older when they win an Oscar than females. However, the oldest person to win an Oscar in that time period was female. That looks like around 80 years old. Okay, so definitely be familiar with that, and we will look at those in just a second. So here's a stem and leaf plot. Again, you can see that key. That's super important if it gives you a set of data and asks you to draw out a stem and leaf plot. So 0 line 8 means 8 whatever. Taki's eaten at lunch. Okay. 1 line 2 would be 12, 17, 18, and 19, 22, 23, 31, 35, and 40. So somebody ate 40 Takis at lunch. Okay, I'm sure that was very hot. But once you start eating them, you just can't stop. Anyways. So with quantitative variables, you're going to have different statistics that you would want to break out. With a categorical variable, you're more so going to be just looking at percentages. What was the percentage or the raw count? That's really the only statistics you have. The percentage or the raw count of action adventure games bought, etc. So with quantitative variables, you have your mean, okay, your average. That's kind of simple. You add up and divide by how many there was. You also have the standard deviation, which there's a nice messy formula for that. And that is the best way of doing that is to use a calculator. Generally in class, I'll go through the process once. It takes like 15 minutes. And then I say, oh, looky here. If you type your data in L1 and then you go to one variable statistics, it does the standard deviation for you. That is way easier and saves you a lot of time. And we'll be doing some calculator stuff on here as the crams go on. Generally, those two go together as well. More on that in a second. The median, which is the number in the middle, it is also known as the 50th percentile, meaning that 50% of the data is at or less than that. The Q1 is the 25th percentile, so that means that the data is 25%. 25% of the data is at that data point or less. That's another change in the AP curriculum that is just a minor change. I really wish they wouldn't have done that, but they did. So percentiles now are at the point or less. It used to just be less, okay? So that if 6 was the 25th percentile, then we're looking at 25% of the data is less than 6. Now it's less than or equal to 6. Little small change there. If you're doing it in your calculator to create that box plot, one variable stats, that's not going to be something that's going to totally kill your score. But that is the way that they break that out now. Same thing, Q3 is the 75th percentile. The interquartile range, the IQR, is you subtract those two quartiles, Q3 and Q1. Basically, you're finding what is the range of the middle set of data, the middle 50%. So the next thing, and Sandra and I both agreed this was important. If you want to calculate if something is an outlier, if you go back to that box plot we were just looking at, you're going to find the, I should have said interval here, not range. You're going to find the interval between, you're going to take the Q1 and subtract 1.5 times the IQR. That's going to be your lower limit, okay? If you're maybe a calculus person, think of limits. So that is your lower limit. Anything below that is an outlier. And then you're going to take the upper limit, which is Q3 plus 1.5 IQR, which is going to be your upper limit. Anything more than that is going to be an outlier and is going to be represented on the box plot by either an extra dot or a little star, but it's not going to fall on the whiskers. Okay, so if we go back to the one that we just had, okay, these are outliers. They're not on the whisker. Okay, so my IQR here appears to be 41 minus 22-ish. 41 minus 22. So the IQR looks like it's about 19 for females. Multiply that by 1.5. That's 28.5. So then I'm going to add that to 48, which is 76.5. So I'm a little bit confused on this box plot here. Oh. Maybe I looked at something backwards. This is 30, not 20. Maybe that was it. So 32. Let's see, 42 minus 22. So the IQR is 20 times 1.5. So I still got 70. Yeah, it is 32-ish. I looked at the scale wrong. 40 minus 32. There we go. That's what it was. I did my IQR wrong. You're right, Rhea. Hope I said your name right. So the IQR looks like it's about 8 or 10 times 1.5 is 12 plus 40 is 52. So anything more than 52, which is right in here, is going to be an outlier. So 60 is an outlier. Yes, the IQR should be about 9. Sorry, I misread my scale there. So just to recap there, because I totally confused that. Totally botched it. The Q3, okay, is this line right here. That is about 40, 41. The Q1 is 32. So then 41 minus 32, the IQR is about 9. 9 times 1.5 is 13.5. And then we're going to add that value to our Q3, which was said was about 41. And that gives us an upper limit of 54.5. So anything more than 54.5 is an outlier. Hence 60, 72, and 80. Okay. And then this value here is the data point. So let's say the next person in line was, it looks like they were about 49. Okay, so this doesn't represent the upper fence. It doesn't represent that upper limit. It represents the last data point that fell within that limit. Okay. All right, let's skip on back ahead. All right, so anyways, that's really important. That's very likely to show up on the AP exam in the free response or the multiple choice section. So now what we're going to do, guys, is we're going to collect our own data. So we're going to use this website down here that is in, the outlier formula is not on the reference sheet. That is a really good question, Presh. It is not on the formula sheet. Make sure that you know that formula. It's one of the few formulas you really need to know. And you need to be able to show your work. So if you were asked to prove that something was an outlier, you want to calculate the formula, compare your data point, and answer yes or no. So like in what we just did, we said that the upper fence was 54.5. The outlier, let's say we're looking at 80. 80 greater than 54.5, therefore 80 is an outlier. You calculated, you did compare with a greater than or less than sign, depending on what fence you're comparing to, and you said yes or no. All right, so you have to make sure you do that. So go to this website here. If the QR code doesn't work for you, Sander has put the link in the chat. You may have to copy and paste it. The class code is EFFED4, and I want you to enter the number of pets that you have. And I'm going to enable data collection for 5 minutes. Okie dokie. All right, so enter the number of pets, and you should see a dot plot that is updating as we are entering those. Oh my goodness. I see so many zeros. That's so sad. Woo, buddy. Enter into the number in the plot. Enter the number of pets that you have. Sorry, I pulled up the data instead of my slides. So we're entering the number of pets we have. Lots of zeros, lots of ones, a few threes. Got a 4. My animal people there. Give us a few more minutes. I really love this tool. It's fantastic for teaching virtually. I think the guy who created it actually worked for Fiveable last year. I think he helped with the streams for calculus and statistics last year. I've never met him or spoken with him, but I think he has. Oh goodness, we got 177. I'm struggling with that one, guys. Yeah. Let's see. All right, I'm gonna, let's see, did it remove that? We'll pause our data collection. All right, so here we go. So here is our data. I guess I shared my admin code with y'all, but anyways, I hope y'all don't try to go in there and do whatever. So anyway, so here's our data, okay? We have a, oh, somebody added a 200. Come on, guys. Come on. Okay. Ants, maybe an ant farm. Yeah, that's possible, I guess. So we have a, here is our data here. We have a dot plot. We also can create some other types of data from it, which we'll do in just a second. So based off of our box, off of our dot plot, how would we go about describing the shape of the data? So put in the chat, how would we describe the shape of the data? Yes, you are exactly right. It is skewed to the right. Okay, so I'm actually gonna pop back over to the slides real quick. It is very skewed right, and I can pull that right back up in just a second as we need to. So what I use, and some people use SOCS. So your teacher might have taught you SOCS, SOCS. Or maybe even two C's. C-SOCS. Some people add context in there. I use CUSS just because it's funny. I love when principals come in my room and we're talking about cussing. So CUSS means you're going to describe the center, the unusual features, which is outliers. Clearly we have one of those. The shape and the spread of our distribution. Okay. It's really important to start by looking at shape, which we've already looked at. Everybody in the chat said skewed right. You were exactly right. It is skewed right. So if it ends up being symmetric, if it looks like a normal curve or maybe a bimodal symmetric curve, that sort of thing, you can use the mean for your center and standard deviation for your spread. If your shape is skewed, like this is here, we need to use median and IQR for those measures of center and spread. And exactly, yes, remember to BS, Sander, be specific, okay? Because we always in stats, I've heard people say no bald numbers. Do not put numbers without context for what we're talking about. We have to have context there. Okay, so we've already said that this was skewed to the right. Okay, so we've already said that is skewed to the right, our box plot. So then what we want to do next, okay, is we want to be sure to clarify the median, which in this case, interestingly enough, the median is 0. Okay, because it is so strongly skewed right, the median is 0. So we would say the median number of pets, again, I added some context there, is 0. Okay. We did center, we've done shape, because that clarified which way we wanted to go in terms of that. Next, we would use, for our spread, we would use IQR, which is Q3 minus Q1. Very easy for this set of data, which is 1 minus 0. So the IQR is 1. You're right. We only have 28 people and 50 numbers. So maybe we had some people doubling up a little bit. I entered mine as well. Okay. So here is, everybody was asking, who in the world has 15 pets? That would be this guy. Okay. I have 15 pets because we have a lot of chickens and 1 duck. Okay. We have a dog, 2 cats, 1 duck, and I think 11 chickens. Last year during the stream, we were up to, I think it was 36 pets. Just crazy. Actually, totally crazy. So we had 36. Our cat, somebody gave us a cat, and our cat had kittens. So it was a buy 1, get 5 free deal. So we were nursing the kittens during quarantine, which was fun. But now I'm glad they're gone because it was a lot. We did keep 1 kitten. His name is Sirius Gray, because he is gray and not black. Anyways, he is really cute. He's probably my favorite pet. We have a dog. We have the mama cat. We still have mama cat. They are spayed and neutered now. Believe me, we did not waste any time when the option was available. And then we had a bunch of chickens that we have since gotten rid of and passed on to other houses. So anyways, yes, free eggs, exactly. So shape is skewed right. The center is 0. It's also the mode. 0 number of pets. So we want to clarify that context. And the shape, we already said shape. So then it brings us to outliers, okay? Clearly there is an outlier. I chose this data set so that there would be an outlier, which is me. I'm the outlier. Whoop, whoop. Sometimes that's good. Sometimes it's not good. And you could easily prove that, okay? The IQR was 1, Q3 plus 1.5 times the IQR of 1, which would be 2.5. So anything over, is that right? We'll see. So actually there's several outliers here, because anything over 2.5 would be an outlier, okay? So I'm a clear outlier. I skewed the data set. It's my fault, guys. I'm sorry. And then 4 and all these 3s are also outliers, mainly because of all these zeros, okay? Most people have 0 pets, and therefore anything over here is going to be considered an outlier. But the clear outlier is the 15, okay? Let's see. Box plot. Again, we have the outliers of 2, 3, and 15. And those are separated from the whisker because of that formula that we've been talking about. And notice here that Q1 and the minimum are the same. So there's not a whisker. Totally bizarre data set there. If it were a more symmetric data set, we would have a whisker over here. And again, this is the middle. So you can see it is strongly skewed right, because from the middle to the right side is way longer than the middle to the left side, which is actually, there is no distance there. Okay. So that is our process on doing that. So let me pull my slides back up over here. Okay. So again, always include context on your cussing the data. On anything you calculate, pretty much in AP Statistics, be sure to include context. It doesn't even hurt when you just calculate an answer to go ahead and write out that answer in context. Okay. All right, so here's another example. It is the U.S. household income. So how many people as a house earn under $5,000? And I know it's hard to see the exact numbers because of the size. It's even hard for me to see on my bigger screen over here to my left. So if we were to CUSS this data, first of all, what would the shape be? So take a minute in the chat and describe the shape of this data here. And while y'all are answering that, I see your question here, Sky. So for there's a lot of ways that you can answer that. Range is generally accepted all the time. But if it is symmetric, you can use standard deviation because, think to going ahead when you're doing things like a normal curve, which is symmetric, the mean and the standard deviation are the two things that you really want. Okay, so you can do that. Let's see what your other question is. If it's skewed, IQR or range, but IQR already gives you the outliers, which if it's skewed, it's very possible that you would have an outlier. Yeah, so it is skewed right. I would say unimodal. It only has one mode if you look real close, okay? That one tip right here at 20 to 25,000 is the top bar. These kind of gradually work up and then it drops off and starts going down, but it is skewed right. So then we would use median to represent that, okay? I would say the median falls somewhere in the $40,000 range, right in here, okay? So a little bit to the right of the mode when it's skewed to the right, okay? So that's where the median would be. Since it's skewed, we want to use median. In this case, I would not use IQR because that would take a long time to try to calculate that. So back to what Sky said, I would use range on this one. I would say that the U.S. household income ranges anywhere from under $5,000 to more than $200,000. Okay, just to show that it's a broad range. I would agree, Sophia, that there does need to be a gap for it to be bimodal. Even if there are two bars right beside each other that were equal, I would still say that's unimodal. But if it were to, peak up here and then peak up again here, then I would say bimodal. So I completely agree. That's a good point there. Two sections, I guess, not just two bars that come to the same height. So yeah, I would use range because IQR would be a pain to try to calculate or even estimate. I would just use range. And again, you can write that out in context and you're go ahead and checking that context box off there. Outliers. Does there appear to be any outliers? Yes or no? See, yes with question mark. Like, I kind of think so, but not 100% sure. I would say there is because of that little bump down here at 190,000 to 200,000. So I would say yes, there is. I would say there does appear to be outliers around $200,000 or in the range more than $190,000. There does appear to be outliers after $190,000 or $200,000. Again, proving that would be a lot because you would have to do IQR, median, and then you would have to create those upper and lower fences or limits and then compare those salaries. And of course, here we don't even know the exact values. We could assume the upper end. I've seen people do that before. We could assume that there was 2,100 people who make $194,999 and overestimate our value. But again, that would take hours to calculate that. So we can give a good estimate that there appears to be. So the center appears to be around $40, $50, $60,000. Anywhere in there is going to be okay. Anywhere on this lower trend. There are some apparent outliers, so I'm just going through CUSS here. On the high end, around 190,000 to 200,000. The shape is skewed right. The spread ranges from $250,000 to under $5,000. Again, so I covered my context here in that very first thing, and I also included dollar signs on everything else that I did. So this would be a great response on the AP Stats exam if you were asked to describe the distribution. Okay, when you see describe the distribution, think CUSS or SOX, whichever one it is that you have been taught. It's the same thing. Okay, and the spelling there. You can add an extra C at the beginning, C SOX, and then C CUSS. That way you don't forget context. Okay, so that is what you're looking at doing. And then, so the next question, it says, compare the mean and median in this distribution. Which is going to be greater, or are they going to be equal to each other in this? So take a minute in the chat and tell me what you think with the mean and the median here. Which one is larger, or are they equal? All right, now the responses are starting to roll in. Gotta love the lag with Vimeo. Yes, so most people agree that the mean would be larger. And the reason why is because the distribution is skewed right, the mean is going to be in the direction of the tail. Anytime it is skewed, the mean is going to be closer to the tail. So if it's skewed right, meaning there's a tail to the right, the mean is going to be somewhere in here. Whereas the median is on that first little downward slope there. So the median is in here, the mean is down here, therefore the mean is greater than the median. If you flip this thing the other way, it's going to look the opposite way. So the mean is going to be closer to the tail on the left, therefore the mean would be less than the median. Okay, that's a huge concept to know, that, and if you think about it, that the mean always goes towards the tail. It's going to be closer to the tail than the median when it is skewed. Now, if they are symmetric, they are approximately equal. Approximately symmetric, essentially equal. Okay, they're not statistically different. I've seen people use that terminology before. When things are close to equal, we can say they're statistically equivalent. Okay, so that's a common question to ask, especially on the multiple choice section. So if you were asked to compare instead of describe, it's the same process. Use context, but you also want to make sure you use comparative words. So for instance, the center of distribution A is larger than distribution B. So if we go back to our box plot, if I were asked to compare these two distributions, I could say that the center, the median age of male Oscar winners is greater than the median age of female Oscar winners. Females had 3 outlier Oscar winners, while males only had 1. The shape of both appear to be slightly skewed right because of the outliers. And the spread of female age is from 20 to 80, while male ages only range from 28 to 75. Okay, so I essentially did the same thing. I did that twice, and I did that using comparative words. The spread for female was larger than males. The center for male was higher than female. The females had 3 outliers, the males only 1, and so on and so forth. Okay, so the same ideas there. I can almost guarantee you will have a free response question, more than likely number 1, on the free response section. If you get univariate data, sometimes they put a bivariate data question on there as well for number 1. But it will ask you one of these 2 things: to compare, describe a distribution based off of a box plot, based off of a stem and leaf plot, maybe a dot plot, things like that. It will show up, and you're just cussing the data, and be sure you include context on that. All right, so here's kind of how we're going to build up to that Cram finale. We got like 1 minute to 1 o'clock. We're coming in right on time. So the 5 things that are non-negotiables for what we talked about today. You have to be able to describe or compare a distribution, because I can almost guarantee you, okay, that will show up on the exam. You need to be able to determine outliers from a 5-number summary. That 5-number summary is your minimum, your Q1, your median, your Q3, and your maximum. If your maximum is larger than that fence we create off that formula, it's an outlier. If your minimum is less than that lower fence, it's an outlier. So we want to make sure we are able to do that. Understanding what shape does to mean and median, that last thing we looked at on that last question, part B. Being able to differentiate between categorical and quantitative. Go ahead and get that worked out now. That way later in the course, you're good to go. And being able to read box plots, frequency charts, to find statistics such as where the quartiles are going to be and where the medians are going to be. And we'll look at some more specific examples for that as we get into the more preparation sessions toward the end of the spring. Okay. So we're taking like 5 non-negotiables from each unit or each stream, and then that Cram finale, and we'll look at examples for all of these non-negotiables. And I'm going to go through maybe the past 10 years of AP exams, free response questions, and make sure that we have touched on at least most of those ideas that you would see. Make sure I didn't leave something off on those non-negotiables, and then I can add something in. So we're kind of creating a Cram study guide here. Okay, so again, social media, Twitter, Instagram, YouTube, tons of great resources on fiveable.me, that link that you should be able to see from the website right now to all the resources with the QR codes as well. And then we're going to keep the conversation going. So make sure you join the Discord in the stats channel, okay? Myself and Sandra will be over there answering questions if there's something we skimmed over that we need to look at again. Also, if you have questions, on your homework as things, as you're working on things for your regular class as well, we can definitely answer that as well. Okay. All right. I hope we had a great first stream. Real quick before we leave, how did things go for you guys on the using the QR codes? Were you able to use the QR code for the Staplet activity? Yes or no on that? Okay, I got a no. I think I'm going to have to adjust the size on my background there. Okay, the links did. Okay, all right, that's fine. I'll work on that and try to get that to work better next time. But the link and the chat with the class code did work. Okay, awesome. Cool, cool, cool. Well, I hope you all have a great rest of your Saturday. Thanks again for showing up, and check out the other resources. Join us on Discord, and I will see you all next week. Same place, slightly different time, and same stats added.